Hi, and welcome to the second of 3 videos for section 3.5. In video 1, we looked at what? We looked at addition, we looked at subtraction, we looked at multiplication. Which one didn't we talk about? Division. That's what this video is going to cover. And you can see from the timestamp, it's a relatively short video, but I'll tell you it's super important. This kind of question will be on your exam, probably going to be on the final exam. So you need to know how to do this. And so to divide complex numbers, so I have one complex number over another. It's very similar, if you want to think of this as our radical problems. When we had a radical in the denominator, we didn't like it there, so what did we do? We rationalized. Same idea here. So to divide complex numbers, we multiply the numerator and denominator by the conjugate, which is exactly what we did when we were rationalizing with radicals. Because it's complex numbers, we don't call it rationalizing, but we are doing the same process. We're multiplying by the conjugate. So let's look at a couple examples. I'll do one. I'll give you another example, let you try that, and that'll wrap up this video. So, the way these problems will be worded, I guess I could do that as one, will be find the real and imaginary parts of the following: 3 plus 5i over 1 minus 2i. Now, what I will tell you, do not do, and I'm trying to stress this because I know some people are still going to do it, don't do this. What so many people do is say, oh, the real part, 3 over 1, it's 3. The imaginary part, 5 over negative 2 minus 5 halves. I'm done. Do you really think that's going to be an exam problem? Just taking what's there and then writing out those numbers? No, right? It seems way too easy. I know I tell you guys to simplify, make math simple, but that's not what we do here. If we have this is division. 3 plus 5i divided by 1 minus 2i. So we need to multiply the numerator and denominator by the conjugate, I guess I should say here, the conjugate of the denominator. So the conjugate of the denominator is what? We have 1 minus 2i, so it's 1 plus 2i. And just like when we had radicals, why do we do that? Well, when we FOIL this, the outside and the inside terms are opposites of each other, so they're gone. Our I pieces disappear because when we multiply the two last ones, we get the I squared, like we saw in the example in video 1, and it turns into an integer for us. So if we do this one, FOIL it. 3 times 1 is 3. 3 times 2i, so plus 6i. 5i times 1, so plus 5i. And 5i times 2i is plus 10i squared. Don't forget that I squared. And the denominator, 1 times 1 is 1. I'll do it here. 1 times 2i plus 2i. 1 times minus 2i minus 2i. And as I said, those guys cancel out. Then negative 2i times positive 2i is minus 4i squared. So let's simplify a bit here. This I squared is negative 1. So 10 times negative 1 means this is minus 10. So on the top I have 3 minus 10 is negative 7. And 6i plus 5i is 11i. So that's my new numerator. How about the denominator? Well, this I squared again is negative 1. So negative 4 times negative 1 is plus 4. 1 plus 4 is 5. So now you can see the I has been removed from the denominator. So now, using my rules of algebra here, I can split each of these up over the 5. So minus 7 over 5 plus 11 over 5 times I. So now I ask you, what's the real and what's the imaginary part? Well, the real part is minus 7/5. The imaginary part is plus 11/5. Again, don't put that I on there, just 11/5. All right, let's do one more example. So we have 7 plus 3i all over 4i. Well, again, the denominator is still a complex number. It just doesn't have a real part attached to it. But we're still going to do the same thing here. So if you want to try it, go ahead and hit pause. If not having the real part confuses you, I'll help you out, and then you can hit pause. If you did hit pause, you tried it, welcome back. If not, this is like what? So maybe this will help. If I do 0 plus 4i. So if that's the case, my conjugate is what? 0 minus, so I can do 0, 0 minus 4i. So 0 minus 4i. So if you want to put that 0 in there, that's fine. So now go ahead and simplify this if you hadn't hit pause before. Otherwise, what do we have? Well, I'm going to erase this 0 to avoid a little confusion here. But that's why we have just minus 4i. It's basically 0 minus the 4i. So if I multiply this, 7 times negative 4i is minus 28i. And 3i times negative 4i is minus 12i squared. In the bottom we have what? Plus 4i times minus 4i is negative 16i squared. So now what do we get? Well, this I squared is negative 1. So the bottom, negative 16 times negative 1 is positive 16. In the numerator, this I squared is negative 1. So this whole thing is plus 12. So I get 12 minus 28i. Simplify this guy. So I can do what? I can factor a 4 out of the numerator, and I get 3 minus 7i all over 16. This 4 cancels with 16, leaves me 4. So I get 3 minus 7i all over 4. So my real part is what? My real part is 3/4. My imaginary part is what? Negative 7/4. So that's how we divide complex numbers. This is how it'll be worded on a test. Find the imaginary, real and imaginary parts of this guy, and that has to be your signal, your bells and whistles, your red flag, whatever that says, oh, I need to multiply by the conjugate. So that's it. Come on back. We'll look at video 3, and that'll wrap up the videos for this section.